Hello everyone, my name is Vinay Kumar. My topic is classless Java. Prototype-based programming. Prototype-based programming is a style of object-oriented programming in which classes are not explicitly defined, but rather derived by addressing properties and methods to an instance of another class, or less frequently adding them to an empty object. This model can also be known as prototype-oriented, classless, or instance-based programming. In simple words, this type of style allows the creation of an object without first defining its class. Prototype-based programming uses generalized objects which then can be cloned and extended. Using fruit as an example, a fruit object would represent the properties and functionalities of a fruit in general. A banana object would be cloned from the fruit object and general properties specific to banana would be appended. Each individual banana object would be cloned from generic banana object compared to the class-based paradigm where a fruit class would be extended by a banana class. The first product-oriented programming language was Cell, developed by David Ungar and Randall Smith in the mid-1980s to research topics in object-oriented design. Since the late 1990s, the classless paradigm has grown increasingly popular. Some current prototype-oriented languages are JavaScript. This PPT presents an object-oriented style without classes, which we call interface-based object-oriented programming (IB). This style is natural extension of closely related ideas such as states. To support the state, IB uses abstraction state operation. This new way to deal with state allows flexibility not available in class-based language. In IB, state can be type refined in subtypes. The combination of a purely IB style and type refinement enables powerful items using multiple inheritance and state. To introduce IB to programmers, we created classless Java, an embedding of IB directly into Java. A classless Java uses annotation processing for code generation and relies on new features of Java 8 for interfaces. The code generation techniques used in classless Java have interesting properties, including guarantees that the generated code is type-safe and good integration with IDEs. Usefulness of IB and classless Java is shown with examples and case studies. Object-oriented language strives to offer great code reuse. They couple flexibility and rigor, expression, power, and modular reasoning. Two main object-oriented models emerged to this and prototype-based PB and class-based languages such as Java, C Sharp, and Scala. In prototype-based languages, objects inherit from other objects. Thus, objects own both behavior and state. In class-based languages, an object is an instance of specific class, and classes inherit from other classes. Objects own state, while classes contain behavior and structure of the state. This paper presents third alternative concept of interface-based object-oriented programming language, where objects implement interface directly. In IB interface, own the implementation for the behavior, which is structurally defined in their interface. Programmers do not define objects directly, but delegate the task to object interface, whose role is to similarly to non-abstract class. In class-based object-oriented programming languages, objects are initiated by static factory methods in object interfaces. A key challenge in IB lies in how to model state, which is fundamental to have stateful objects. To all to all abstract operations in an object interface are interpreted as abstract state operations. The abstract state operations include various common utility methods such as getters and setters or clone-like methods. Objects are only responsible to define the ultimate behavior of a method. Anything related to state is completely contained in the instance and does not leak into inherited logic. Inheritance logic. In CP, the structure of state is fixed and can only grow by inheritance. In contrast, in IB, the state is never fixed, and methods such as abstract setters or getters can always receive an explicit implementation down in the inheritance chain, improving modularity and flexibility. That is, the concept of abstract state is more fluid. Object interfaces provide support for automatic type refinement in construct. In CB, special care and verbose explicit type refinement are required to produce code that deals with subtyping adequately. We believe that use verbosity hindered and shown slowed down the type discovery of useful programming patterns involving type refinement. A recently discovered solutions to expression problem in Java-like language shows how easy it is to solve the problem using only type refinement. However, it took nearly 20 years since the formulation of the problem for the solution to be presented in literature. In IB, due to its emphasis on type refinement, that solution should have been obvious. One advantage of abstract state operation and type refinement is that it allows new approach to type-safe covariant mutable state. That is, in IB, it is possible to type refine mutable fields in subtypes. This is typically forbidden in CB. It is widely known that naive type refinement of mutable fields is not type-safe. Although the covariant refinement of mutable field is supported by some type field systems, this requires significant complexity and restrictions to ensure that all users of covariant state are indeed type safe. Another advantage of IB is the support for multi-inheritance. The literature shows how easy it is to combine multiple sources of pure behavior using traits. In Java, multiple interface inheritance has been supported since inception, and Java 8 default methods bring some of the advantages of the traits to Java. The literature is also rich on how hard it is to combine multiple sources of behavior and state with multiple implementation inheritance of classes. In IB, there is only multiple interfaces inheritance, yet programmers can still use state via abstract state operations. IB enables powerful items using multiple inheritance and state. IB could be explained by defining a novel language with new syntax and semantics. However, this would incur a steep learning curve. We take a different approach instead. For the sake of providing a more accessible explanation, we will embed our ideas directly into Java. Our IB embedding really relies on the new features of Java 8, interface, static methods, and default methods, which allow interfaces to have method implementation. In the context of Java, what we propose is a programming style where we never use classes. More precisely, we never use a class keyword. We call this restricted version of Java classless Java. Using Java annotation processors, we produce an implementation of classless Java which allows us to stick to pure Java 8 by annotating the interface that represents Java object interface with OBJ code for interface instantiation and type refinement can be automatically generated. Such code should not be needed in the first place in a real IB language, and the annotation process allows us to transparently hide it from Java programmers. The implementation works by performing ASG rewriting, allowing most existing Java tools to work out of the box without implementation. Moreover, the implementation blends Java's conventional CD style and IB smoothly. As a result, we experiment object interface with several interesting Java programs and conduct various case studies. Finally, we also discuss the behavior of our OBJ annotation and its properties. While the Java embedding has obvious advantages from the practical point of view, it also imposes some limitations that new IB language would not have. Supporting proper encapsulation is difficult in Java due to the limitations of Java interface. In particular, in Java interfaces, the visibility of all methods is public, thus modeling private shooting is difficult in current Java. However, using existing design patterns, we can emulate hiding methods from interfaces. Furthermore, Java 9 will allow private methods in interface. In summary, the contributions of this paper are IB IB and object interface, which enables powerful programming items using multiple inheritance, type refinement, and abstraction operations. Classless Java, a practical realization of IB in Java. Classless Java is implemented using annotation processor, allowing most tools to work transparently with our approach. Existing Java projects can use our approach and still be backward compatible with their clients in a way that is specified by our safety properties. Types of covariant mutable state issue how the combination of abstract state operations and type refinement enables a form of mutable state that can covariantly refine in a type-safe way. A running example animals. This section illustrates how our programming style, supported by object, enables powerful programming items based on multiple inheritance and type refinement. We propose a standard example. Animals with a two-dimensional point 2D represent their location, subtypes, hash codes, and packages. birds can fly, thus their location need to be 3 dimensional. Point 3Ds. We model Pegasus as well-known creature in Greek mythology as a kind of animal with skills of both horse and birds, multiple abilities. Like simple class diagram illustrating the basic system of given simple with multiple filters with default methods. Before modeling in the complete animal system, we start with simple version about locations. This version serves the purpose of illustrating how Java 8 default methods can already model a simple form of multiple inheritance. Horse and birds are subtypes of animals with method run and fly. Respectively, Pegasus cannot not only run but also fly. This is the place where multiple inheritance is needed because Pegasus needs to obtain fly and run functionality from both horse and bird. The first step to obtain institute to model the animal system is given on the right side of the figure. Note that the implementation of the methods run and fly are defined inside interface using default method. Moreover, because interface supports the multiple inheritance, Pegasus inherit the interface of Pegasus can inherit behavior from both horse and bird. Although Java interface does not allow instance fields, no form of state is needed so far to model the animal systems. There are some annoyances here. Firstly, the sole purpose of the class is to provide a way to initiate objects, although it takes only one line of code to provide each of these classes to system. Secondly, the namespace gets filled with 3 additional types. For example, both horse and horse implement are needed. Horse is needed because it needs to be interface so that Pegasus can use multiple agents. And horse IMPL is needed to provide object institution. Note for this very simple animal system, plain Java anonymous classes can be used to avoid these problems. We could use simply initiated Pegasus using Pegasus Pegasus anonymous class. Conclusion. Before Java 8, concrete methods were not allowed to appear in interface. Java 8 allows static interface methods and introduces default methods, which enables implementation inside interfaces. An important positive consequences that was probably overlooked in the concept of class in Java is now almost redundant and unneeded. We propose a programming set classes are where truly object-oriented program and reusable libraries can be defined and used without ever defining a single class. However, using this programming style directly in Java is very perverse. To avoid syntactic boilerplate caused by Java not being virtually designed to work without classes, we introduce the obj annotation that provides stricter information for the English methods and mechanism to initiate objects. We leverage on annotation process and Bambam library. In this way, obj is just a normal Java library, and the obj annotation helps programmers to write less cumbersome code while coding in classless Java. Indeed, we think the optimal gain is so high that classless Java with obj annotation can less cumbersome than full Java. Thank you.